Welcome to ClickMyProject.com. The title of the project is Deep Learning Fine-Grained Hierarchical Learning Approach for Robust Malware Classification. And the abstract of the project is Internet of Things has emerged as a cutting-edge technology that is changing human life. The rapid and widespread applications of IoT, however, make cyberspace more vulnerable, especially to IoT-based attacks in which IoT devices are used to launch attack on cyber security physical system. IoT Anomoly detection system based on the analysis of IoT network features. First, we use an auto-encoder network to gather the latent presentations of the input data, the acceptance of the Internet of Things for both household and industrial applications in accompanied by the rapid growth of IoT malware. With the increase of the attack surface, analyzing, understanding, and detecting IoT malicious behavior are crucial. This proves that autoencoder network can compare the IoT network features and keep only the most meaningful features. The model latent representant classifies IoT malware reduction high performance. The bottleneck layers of these regularized autoencoders training in the supervised manner using normal data and known IoT malware which then be used as the new input features for classification algorithm to evaluate the performance using machine learning and deep learning algorithms. Our proposed method, we developed random forest classifier, convolutional neural network classifier, and deep neural network classifier to detect the IoT malware and estimate the performance in terms of accuracy. And the flow diagram of the project is, first we need to start the program and select the malicious datasets. In the dataset contains three different malicious attacks like benign dataset and GUI GPT dataset and Mirai dataset. So these are all the dataset that we are used to detect if it is a malware attack or not by using those algorithms. First we need to select the dataset and we use the sample dataset in our console working directory. After that it will apply into data pre-processing method. In data pre-processing we are going to check the missing values. After that we need to apply the label encoder to convert the string values into unique numerical values. After that it will apply it into feature extraction or feature selection or model selection, which is used to split our dataset into training dataset and testing dataset in the ratio of majority and minority portion. Like train data contains majority portion and test data contains minority portion. Then it will apply into classification method. In classification we are going to apply the three different algorithms, like one machine learning algorithm and two deep learning algorithms. The machine learning algorithm like random forest algorithm and deep learning algorithms like convolutional neural network and deep neural network algorithm. Finally we are going to predict whether if it is a malware or benign. Then we are going to generate the result in terms of accuracy, precision, recall and F1 measure. I was executed my program in Anaconda Navigator Spider IDE. So these are the result of my program. So overall in here I am using 10 different datasets to find if it is the benign or malicious by using the machine learning and deep learning algorithm. So this is our first module. In that module I have to read our dataset and I will show the sample dataset in our console working directory. So after that I have to check the information about our dataset. So after that I have to describe our dataset. While describing I can get the count value, mean value, standard value, minimum to maximum value for every column that contains in our dataset. So this is our second module, pre-processing module. In pre-processing I'm going to handling the missing values. So while checking the missing values it will show the result is false. So after that I have to check the individual columns and it will show 0 for every columns. So then I'm going to choose the independent variable and dependent variable. So independent variable considered as the input and dependent variable considered as our target value or output value. So after that I have to split our x into x train and x test and y into y train and y test and test data set. So that was the third module. And fourth module, feature reduction. So in feature reduction I'm applying the PC algorithm, so principal component analysis algorithm, which is used to take the best features from our data set. So in here I am choosing only 25 best columns to find the benign or malicious from our data set. So and our fifth module is classification. So in classification first I am applying the random forest algorithm. So the random forest algorithm shows the accuracy is 99.89%, and these are all the classification report for random forest algorithm. So these are all the precision, recall, F1 score values for the benign and malignant classes. So the precision means number of correct prediction, recall means number of correct instance of prediction, and F1 score means to measure the test accuracy. So this is the confusion matrix result. So and this is the learning curve, so the random forest learning curve, and this is the confusion matrix diagram. So the confusion matrix result, which is express the number of correct classification and number of misclassified result that we have to obtain from our machine learning algorithm. So our second algorithm is convolutional neural network algorithm. So these are all the layers that we have constructed the convolutional neural network algorithm. So in here we are using convolution layer, max pooling layer, dropout layer, flatten layer, and dense layer. 5 different layers are we are using. So our algorithm takes overall parameter is 2,07,628. So all the parameters are in trainable form. So as per the trainable parameter, our CNN algorithm will go into train our data set and get the accuracy result at 99.67%. So these are all the performance graph for convolutional neural network algorithm. So and this is the classification report for convolutional neural network algorithm, and this is the confusion matrix for convolutional neural network algorithm. So our final algorithm is deep neural network. So the same we are going to apply the 5 iterations to get the accuracy. So our deep neural network shows only 94%, and this is the performance graph for our deep neural network algorithm, and this is the classification report for deep neural network algorithm, and this is the confusion matrix for our deep neural network algorithm. Finally we are going to compare the three algorithms, and these are the comparison between the random forest, convolutional neural network, and deep neural networks. And